Hello, today we learn how to draw the Lewis structures of molecules or the polyatomic ions given. So to draw the Lewis structure of a molecule, one thing we need to know is how to calculate the valence electrons of that molecule. Let us take the example. Suppose we are told to draw the structure of CH4. Now the first thing what we'll do is we'll calculate the total number of valence electrons. Now carbon, because it is present in group 4 or 14 of the periodic table, so it has 4 valence electrons, plus hydrogen has 1 valence electron, and because it has 4 atoms, so that being multiplied by a 4 gives us a total of 8 electrons. Now we have to deal with these 8 electrons. The next thing what we are going to do is put one atom in the center. So out of carbon and hydrogen, we'll put carbon in the center because carbon usually it forms 4 bonds and hydrogen it forms only 1 bond because hydrogen has 1 valence electrons. So the atom which forms more number of bonds is added in the center and the other atoms are just placed around that. So we put 4 hydrogens over here. Now they need to have at least 1 bond between them. So we have drawn 1 bond each between the carbon and the hydrogen. To make 1 bond, 2 electrons are required, and because we made 4 bonds, so 4 times 2, we have used 8 electrons. So we had 8 electrons and we have used all the 8 electrons. We are left with nothing. Let us check. So hydrogen is good with 2 electrons. This hydrogen also has 2 electrons. So all the hydrogens are satisfied and stable, and carbon it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this structure is the Lewis structure of methane, which is CH4. Now let us try drawing the structure of other molecule, which is CO2. For drawing the structure of CO2, we again need to have the total number of valence electrons in carbon dioxide. So carbon has 4 valence electrons. Oxygen, because it is present in group 6 or 16, so it has got 6 valence electrons, and multiplied by 2 just because it has got 2 atoms. So 6 times 2, 12. 12 and 4 is 16. So here, carbon dioxide, we have a total of 16 electrons. Now carbon will be placed in the center because carbon forms 4 bonds and oxygen can form only 2 bonds. So 2 oxygens placed around it. Now we have to make at least 1 bond between the carbon and the oxygen. So by making 1 bond, what we have done is we have used 4 electrons in total. So 16 subtract 4 electrons, we are left with 12 electrons. Now the next step is to satisfy the octet or the duplet of the peripheral atoms. It means the atoms which are towards the outer part. So this oxygen, it has already 2 electrons. So to make it complete or stable, we have to add 6 more electrons to it. So 1, 2, 3, 4, 5, 6. So this makes the total number of electrons with this oxygen 8. And the same thing we are going to do with the other atom on the left. So 1, 2, 3, 4, 5, 6 we have added, and 2 it already had. So it makes it 8 for this oxygen also. So we have used a total of 6 and 6, which means 12 electrons have been used. So we are not left with anything, which means we cannot give any more electrons to this carbon. So this carbon right now has 1, 2, 3, 4 electrons. It is not stable. We need to make it 8. So what we are going to do is we are going to remove a lone pair of electron over here and put it as a bond pair. The same thing we are going to do on the other side, because after that sharing also it still has 6. We need to make it 8. So removing one more lone pair and putting it as the bond pair. Now oxygens, they are all fine. 1, 2, 3, 4, 5, 6, 7, 8. And now the carbon is also stable with its 8 electrons. Let us try drawing the structure of a polyatomic ion, which is ammonium ion. So NH4 with a 1 positive charge. So to calculate the total number of valence electrons, nitrogen has 5 plus hydrogen has 1 times 4. One additional thing, because it has a positive charge, which means it has given off 1 electron. So we are going to subtract 1 from it. So we have now 5 plus 1 times 4, which is 9. Subtract 1, we are left with 8 electrons. Now nitrogen again comes in the center because it has a tendency to form 3 bonds, hydrogen 4 of them placed around the nitrogen. We need to have at least 1 bond between them. So we made 4 bonds for which we have used a total of 8 electrons. So all the 8 electrons are lost. We don't have anything, but all the hydrogens are also good because they have a total of 2 electrons, and nitrogen is also good because it has a total of 8 electrons. One thing you need to remember is, because we are drawing the lowest structure of an ion, a polyatomic ion, so we need to put a square bracket and put a positive charge outside it, indicating that 1 electron by this one has lost. One more thing I want you to know over here is that though nitrogen forms only 3 bonds, but you can see the 4th bond over here. So this is actually not a covalent bond. It is called as a covalent coordinate or a dative bond. So if you want to understand this in detail, you can just watch the video regarding the covalent coordinate or dative bond and you'll understand that topic clearly. Now let us try out the lowest structure of a polyatomic ion, which is negatively charged. So let us take a phosphate ion, which is PO4 with a 3 negative. So here now phosphorus, it has a total of 5 valence electrons plus oxygen has 6 multiplied by 4, just because oxygen has 4 atoms, and a 3 negative charge indicates that the 3 electrons have been accepted by it, so we need to add 3 to it. Now the total number of electrons are 5 plus 24 plus 3, which makes it a total of 32 electrons. Now let us try drawing the structure. So here again, phosphorus, it has to be placed in the center because phosphorus can expand its octet and it can make a total of 5 bonds, and oxygen can only make 2. So phosphorus comes in the center and we have to place 4 oxygens around it. Now we'll draw at least 1 bond between each one of them. By doing this, we have used a total of 8 electrons. So 32 subtract 8 gives us 24 electrons. Now the next thing we have to do is satisfy the octet of the peripheral atoms. So this oxygen needs 1, 2, 3, 4, 5, 6 more because it already has 2 electrons. So with each of the oxygen, we will put 6 electrons, and let us see how many electrons we've used in total. So we have used a total of 24 electrons because 6 times 4 is 24, and we are not left with any electron. Now one thing I want to clarify over here, that though this phosphorus seems to have complete its octet, but from the periodic table over here, you can see that phosphorus is placed over here. So because it is below nitrogen, nitrogen can form only 3 bonds, but phosphorus can have a tendency to form all the 5 bonds, all the 5 electrons, the valence electrons which it has, it can share. Similarly, the sulfur present over here, oxygen can form only 2 bonds, but sulfur present over here can make 6 bonds. Fluorine can make only 1 bond, but chlorine can share all its 7 electrons. So these elements have a tendency to expand their octet, which means after sharing, phosphorus can have 10 electrons total, sulfur can have 12 electrons, and chlorine can have 14 electrons. So what we will do is to satisfy that condition that phosphorus can form 5 bonds. So what we are going to do is we'll remove a lone pair from any one of the oxygen atoms and put a bond pair. So now phosphorus has those 5 shared pair of electrons, and now because this is a polyatomic ion, so we need to put a square bracket and indicate a 3 negative charge, stating that there are 3 electrons which have been accepted by this phosphate ion for getting involved in this bond formation. One more thing to tell you over here is beryllium and boron. They are those 2 atoms which are good even if their octet is not complete. So beryllium is usually good with a total of 4 electrons after sharing, and boron is good with a total of 6 electrons after sharing. So we can check out one structure. So let us try drawing the structure of beryllium hydride. Now over here, beryllium has 2 valence electrons plus hydrogen has 1 multiplied by 2. So we have a total of 4 electrons. We'll put beryllium in the center and 2 hydrogens around it. And now we have to make at least 1 bond between them. So we have used a total of 4 electrons and we are left with nothing. Now you can clearly see that beryllium after sharing, it has only 4 electrons. On the top of that, we do not even have any lone pairs on hydrogen, which we can change as a bond pair with beryllium. So beryllium is good with its 4 electrons after sharing. Same way, boron is good with its 3 electrons after sharing. So I hope you understood and enjoyed the process. See you in the next one. Bye-bye.